And now let's go over reciprocal functions. So reciprocal functions are typically denoted by f of x is equal to 1 over x. And the nature of reciprocal functions are really straightforward. If we were to go over the domain and the range accordingly, they're both going to be the same. Because since reciprocal functions are typically denoted as functions, there's always one general rule. We cannot divide by 0. And again, these functions are very straightforward. There's not that much to be able to go further in depth on. As long as we know the general rule, we can already pinpoint their nature of why they behave in such a manner. And without further ado, let's go over our first practice problem. So now, whenever we are focusing on our first practice problem, we are given the case of when we have 1 over 2 minus x, and we got to figure out how to graph it. Well, again, as we know with the general rule, cannot divide by 0. And reciprocal functions are typically always going to be the same, to an extent, depending on exactly what we're getting. So nature / structure would be the same. So all we got to ask ourselves is, what can we plug into x that will give us 0? Which will give us 0. We can even you can also plug in at the same time, but it's very straightforward that if we plug in positive 2 in this case, just positive 2, we're going to get 1 over 0, which is very self-explanatory. So therefore, what we can say with our graph, let me just move up. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2, 3, 4, 5. 1, 2, 3. Okay, there we go. So that a reciprocal function is going to be denoted right over here. So whenever we are hitting 2, in this case, and y is 0, so we have x and y, which is 2, 0, that is where it completely intersects. So we would have, in our case, negative infinity all the way to 2 in unison, 2 to positive infinity for our given domain. The range, on the other hand, will likely be the same, 2 unison, 2 infinity over here. However, a big however, we also need to figure out exactly what the y-intercept is going to be. And it's pretty self-explanatory. Whenever we have the y-intercept, that would be when x is 0. And so we would, I'm just going to move this up a little more. There we go. So that way we can denote that our intercept over here is going to be, looks like, when x is 0, then we have 1/2 over here. 0 at y. Intercept. And so, yeah, this is our first practice problem. Now let's head over to our second practice problem. Now, for our second practice problem, we're going to have our following function. Y is equal to 1 over x minus 3, where in this case, what we would have is, we can actually just pinpoint our graph over here. We just need to figure out exactly where the reciprocal function will split. Then afterwards, where the y-intercept is located. Those are just the big 2 points that we have, so let me just put our y and x-axis. We're going to figure out what the domain and ranges are. So we have a bit of a hack whenever we are doing this. So in this context with what we have, we can actually determine where specifically our axis of symmetry is going to be located. So since we have this -3 over here, it's actually going to be right here. So this is where the magic will happen, where we're going to have a line split. But we got to figure out exactly where the y-intercept is located. And the y-intercept is always denoted whenever x is 0. So when x equals 0, it's pretty straightforward. So that means that y will equal, well, it looks like since nothing can be divided by 0, the whole equation completely goes off. So there is no y-intercept. Cannot divide by 0. Doesn't make any sense. So there is no y-intercept, and so we can just pinpoint this bad boy over here, and it will just go in its normal fashion between the curves, as we already know. And the whole equation that we know, let me just put this right here, 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 and here. So we have -infinity to -3, all the way up in unison with -3 to +infinity for our domain. Let me just make this and put it back over here. Clean this up a little bit more. There we go. Nope, there we go. Infinity to +infinity, and the ranges, the same case, -infinity to -3. Unison with -3 to +infinity. All right, and so let's move over to our next. Let's focus on our next function, square root functions. Hey everyone, thank you again for taking time to watch this video. If you found this video helpful, be sure and feel free to please like and subscribe, smash the like button, and ring the bell for any notifications as well. And if you have any other questions, by all means, feel free to put it in the comment section as well. And as always, take care. Cheers. Bye-bye.